This is a lesson summary video for the task titled More or Less. This is a practice understanding task. The purpose of this lesson is to practice solving systems of linear inequalities. So let's start with the systems of inequalities that's represented graphically. The first question asks, where are the solutions? So the solutions are in this double shaded region. So any of the points in this double shaded region over here, which is like kind of a darker purplish. So all of these points in here, they can also be on this boundary line, but they cannot be on this dotted boundary line. Can't be here. So any of these points in the double shaded region are solutions to the system of inequalities because they will satisfy both inequalities. And so now that we have found the solutions, let's go ahead and write the inequalities. So I'm going to remember slope-intercept form for this because I'm taking the points off the graphs. So slope-intercept form is y equals mx plus b. And let's start with this one that's kind of a reddish color. So my y-intercept is 2, and my slope, I go down, let's go down 2 and over 5. So down 2 and over 5. All right, so I'll start with just what the line is, and then I'm going to come back and worry about my inequality sign. So I have substituted in my y-intercept and my slope. Now to get the inequality sign, I don't want equals because I have shading that's underneath the line. So I have a solid line and I have shading underneath the line. So that means I'm going to have less than or equal to. The equal to because it's a solid line, the less than because it's y is by itself and the shading is below. If you're not sure about whether or not it should be less than or greater than, then you can always try a test point. So I like to choose the test point 0, 0 right here. Now I can see that 0, 0 is in the shaded region. So if I substitute 0, 0, the point 0, 0, 0 in for x, 0 in for y, then I should have a true statement if I got my inequality symbol correct. So here I've substituted in the point 0, 0, 0 for x, 0 for y. And when I simplify this, I have 0 is less than or equal to 2. Now that's a true statement, so I can feel confident with the symbol that I chose. So if you have y by itself, you can look to see if it's shaded below or shaded above. If it's shaded below, you'll have less than. If you shade it above, you'll have greater than. But if you're not sure, always try your test point. The test point will work. And again, it is less than or equal to because this is a solid line. All right, let's get the other one. So for this blue line here, it's shaded above, so I'm going to have greater than, and it's a dotted line, so I know it's going to be greater than instead of greater than or equal to. So I'll start off with y is greater than, and I'll get my slope and my y-intercept. So this is at -1, and my slope is, let's see if I go up to over 1. Let me check it again over here where I can see clear. Up to over 1. So my slope is 2, so then I'll have an x, and then my y-intercept is -1. Again, if I wasn't sure about the shading, I could try the test point. So if my test point is 0, 0, I'll substitute 0 in for y, 0 in for x, and make sure that that's a true statement because it is in the blue shaded region. So that's 0 is greater than -1, which is a true statement. So the system of inequalities that is graphed here is y is less than or equal to -2/5 x plus 2, and y is greater than 2x minus 1. And the solution to this system is this double shaded region, because there is an infinite number of points that satisfies these two inequalities at the same time. All right, let's take a look at another example. So let's solve this system. So now I have the equations and I want to represent the solution on the graph. Since there's an infinite number of possible solutions, that's why I'm using a graph to represent them, because I can't write them all down. I need to graph them and then shade the area that where the solutions are. So to graph these, that's where I'll start. I'll graph one at a time. So I'll start with the top one. So 2x plus 3y is less than or equal to 18. Now, since this is in standard form, I'm going to just solve for my x and y intercepts so that I can get 2 points on the graph, and then that'll make it a little easier to graph. So if I'm solving for my x-intercept, I'm going to make y 0. So I'm going to put 0 in for y, and I'll bring down the rest of the equation. And I am going to solve this as an equation because I want the x-intercept, so I'm going to set it equal to 18. So I want to see exactly where if just the line, not the inequality, where the x-intercept is. So this makes 0, so I have 2x equals 18, and x equals 9. So I'll go over to 9, and I'll put a point right here. Because when y is 0, x is 9. Now I'll solve for the y-intercept, so I'll make x equal 0, and I just have to, remember, set it equal because I want to know where it is equal to 18. So then I have 3y equals 18. When I divide by 3 on both sides, I have y equaling 6. So I'll go up here and I'll put a 6. Now this has a line underneath it, so when I draw my line, I want to make it a solid line. And then to figure out where I want to shade, I'm going to use a test point. So I'll pick 0, 0, my favorite test point, and I'll put, go back to my original inequality, substitute 0 in for x and y, and I'll see if this makes a true statement. So this is 0 plus 0. 0 is less than or equal to 18. So that means I'm going to shade this region. All right, so that's one inequality. Let's do the other. So I'll start with finding the x and y intercepts. So 4x minus 5, I'll find the x-intercept. So I'll make y equals 0. And I'm going to put an equals 20 because I want to find when y equals 0 what x is. So it gives me 4x equals 20. So when I divide by 4 on both sides, I get that x equals 5. Then I'll substitute 0 in for x and solve for y. When I divide by negative 5 on both sides, I get that y is equal to negative 4. So my x-intercept is at 5, and my y-intercept is at negative 4. This time, I'm going to have a dotted line, and when I check to see where I need to shade, I'll use my test point 0, 0 again. So I'll put 0 in for x and 0 in for y. And when I simplify the left side of this inequality, I have 0 is greater than 20, which is not true. 0 is not greater than 20. So 0, 0 does not get shaded. So I'm looking at the other side of the line. All right, so I have a lot going on with my graph here. So let's look at the part that's double shaded. It's just going to be this section over here. So I can be on this part of the line over here, but I can't be on this boundary line over here. I have to be just right below it. And then all of this section down here is included in the solution to this system. So any of these points down here, and then not on the line, but right up to the boundary line here, and then on this boundary line. That's where my solution is. Okay, that's it for this video. Thank you for watching.